Good day, everyone. I am Kyle Joshua Munoz, a research assistant in UP Visayas, presenting our study on chitin extraction using deputectic solvent. First, you can scan the QR code on the poster for a more detailed presentation of the study. The main highlight of the study shows that deputectic solvents can extract chitin from blue swimming crab shells. So specifically, we used malonic acid choline chloride and urea choline chloride for the deputectic solvents. So the results show that it was very advantageous compared to the conventional method, which is the acid-base extraction, compared for the factors like cost, time, and energy consumption. Lastly, the chitin extracted is also on par with commercial chitin after characterization of several characterization techniques. So the research project focused on the blue swimming crab shells in Estancia, Iloilo. Shells of these crabs were then processed into chitin using the aforementioned deputectic solvent and was characterized using XRD, SEM-EDS, FTIR, and TGA. For the results, the mentioned characterization techniques showed that the chitin extracted from the blue swimming crab shells using the deputectic solvent extraction are on par of the Aldrich chitin. The deputectic solvent extraction method shows promising results as an alternative mode of extraction for chitin in terms of yield, cost, time, and energy consumption, as seen in the figure where the extraction factors percent difference of urea choline chloride in the black and malonic acid choline chloride in gray with the conventional method. For morphology and elemental composition of the chitin, arrange surface of microfibers with particle size of 50 to 150 micrometer per particle was observed, and upon magnification, it shows fibular structure morphology around 0.3 to 0.5 micrometer with and gaps with 1 micrometer in diameter. So as expected from the EDS results, carbon, nitrogen, and oxygen was detected in all extracted chitin. For the thermogravimetric analysis of chitin, three decomposition steps were observed. So the first mass loss, as seen in the figure, is correlated to moisture. The second mass loss is correlated to the saccharide backbones, which includes the dehydration of the saccharide rings. And lastly, the third mass loss is correlated to the carbonization um, of chitin. Yes. So, so next for the FTIR also showed promising results, as it shows the chitin extracted was an alpha chitin. Also, if compared to the blue swimming crab shell, which is the color pink spectra, it showed that the protein and the calcium carbonate peaks were removed after the DES extraction. For the X-ray diffraction analysis of chitin from blue swimming crab shells, XRD patterns of the obtained samples showed that both extraction methods are relatively same at patterns at degree 12, 19, 20, and 26, which proves that the crystal system of the chitin extracted from deep eutectic solvents are somehow relative with the Aldrich chitin. Next, it also proves that the deep eutectic solvent extraction method was successful since it showed the removal of the calcium carbonate peak, which is showed or seen in the crab shell pattern. So overall, we can say that both deputectic solvents, malonic acid choline chloride and urea choline chloride, are effective solvents for chitin extraction. Further assessment on the quality of chitin and optimization of methods may be needed. Thus, the study shows promising results on chitin extraction. Thank you. We thank the institutions that funded this project, Commission on Higher Education, Dare to Research Grant, UP Visayas PACP or Philippine Association of Crab Processors Incorporated, and the help of Regional Research Center for the Characterization Techniques.